It is 10 o'clock a.m. Central Standard Time here in North Central Texas at the Dallas Independent School District STEM Environmental Education Center. We want to welcome you and we appreciate that you're joining us this morning. Teachers, if you're watching and you have not registered, please do that. Go to www.tiny.cc/EEC register. Sign up. This is just for our attendance records only. This morning, we're going to do a program called Energy and Resources. During this virtual field trip, students will evaluate how the use of energy, water, mineral, and rock resources affects Earth's subsystems. They will also differentiate between renewable and non-renewable resources based upon rate of formation and use. Ms. Ramirez will do a program called Energy and Water Resources. Ms. Fuller will cover mineral and rock resources. Mr. Monroe will tell you about renewable resources, and Ms. Nash will inform you about non-renewable resources. You cannot verbally talk to us, speak to us, but you can go to www.tiny.cc/EEC /question/answer and send in a question. We'll do our best to answer them. Now I'm going to stop sharing my screen. And Ms. Ramirez will tell you all about energy and water resources.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about energy resources and also how water use affects the environment. So I'm going to go ahead and share our screen, and we'll get started with our presentation. So let me get that screen share started. So I have an essential question for you guys, and hopefully by the end of this segment, you'll be able to answer this question. And the question is, evaluate how the use of energy and water resources affects Earth's subsystems, and then give 2 examples. So keep that question in mind as we go through the presentation so that you can answer that. And just a quick review, the examples of Earth's subsystems include the biosphere, which include the living things like plants and animals, the hydrosphere, which would include water, the geosphere, land and rocks, and atmosphere, the air. So as we talk about these energy sources and our use of water, think about how those impact these 4 subsystems of planet Earth. So I'm going to go ahead and continue on with the presentation. Again, keep that essential question in mind so that you can answer it later. The first energy source we're going to briefly talk about is just solar energy. So I have a quick little video to show you guys. As you watch the video, be thinking about what are some pros and cons, and then how does this energy use affect Earth's subsystems? So remember those 4 subsystems mentioned earlier. So this video is going to be about the solar project in the Mojave Desert, and it encompasses over 5 square miles in California and Nevada. And it's a $2.2 billion solar project, and it's one of the most massive solar projects in the US. And it has a solar tower that is over 750 feet high. And this video is going to go over some of the implications of this solar project. Now, what you're seeing there is the solar tower, and it actually releases a beam. It's a concentrated, super hot beam that can actually hurt wildlife, including those flying birds. And so that video kind of shows you all those solar panels, how all that energy is being channeled into that tower. And that energy is creating steam. So you can see in this video here, we have a little container with water. It's creating steam that runs a turbine, which is then what's being used for that solar power. And then you can see how sometimes wildlife like birds get caught in that super hot, intense solar beam. So obviously that would be a negative impact on the biosphere, our living organisms in planet Earth. Also think about the hydrosphere. So something that I didn't know is that a lot of these large, massive solar plants, they have to constantly use a lot of water to cool down the machinery. So that might drain some of the local water resources. So that's how it might affect the hydrosphere. But on the good note, because this is solar energy, it doesn't produce air pollution or greenhouse gases. So that's a positive for our environment, particularly for the atmosphere, because we're not releasing any pollution into the atmosphere. So there's less pollution both in the air, but also in the water, because that air pollution is not impacting the hydrosphere. And then some other impacts when we talk about the land, maybe for the biosphere and the geosphere, they have to clear quite a bit of land for these solar plants. So that clearing the land, the construction process, we might habitat some fragments, cause habitat fragmentation in some areas. So those are just a couple of pros and cons to solar energy. Honestly, I think it's more on the positive side, because there's less air pollution and use of those pollutants like might cause greenhouse gases. The next one we're going to take a look at is wind energy. And again, think about how it affects those subsystems. So a positive for wind energy, just like solar energy, it doesn't release emissions. It doesn't require cooling either, like the solar energy does. And there's no or few energy from fossil fuels. So it lowers, again, the total air pollution and CO2 emissions into the environment. So that's a positive for Earth subsystems. So there's less pollution in the atmosphere, less pollution in the hydrosphere. So that's a plus. But as you can see in this little diagram here, it actually contributes to some bird and bat deaths. So that might be a con for the biosphere. And also, just like with the solar projects, it might increase habitat loss or land fragmentation. And also what I wasn't aware of was that they have to oftentimes create a lot of access roads to these wind farms, but also they have to build new transmission lines to these wind farms. So that might also affect the environment as well. So that's wind energy. The next one we're going to take a look at is hydroelectric energy, which is water energy, and then also how our water use affects the biosphere and other subsystems as well. So take a look at this diagram here and see if you can infer what this diagram is telling us. So the first thing that I noticed right away is that the majority of water on Earth is salt water. So it's not readily usable for us. Only less than 3% is actually fresh water. And of that, less than 3%, you can take a look, about 30% is groundwater and about 70% is glaciers and ice caps, which we can't use. So even though we start off with a super small percentages of fresh water, and even smaller percentage of that fresh water is what we can actually use. So even though we are the blue planet, we have tons of water, not a lot of it is actually able for us to use. And then if we take a look at the diagrams here, we can see how how our industry and other things in the environment can negatively impact the hydrosphere. So we see pollution here, which obviously impacts the hydrosphere, but also think about the biosphere. How are those animals and plants being impacted by water pollution as well? And then this next little video, something interesting that I learned. I like to watch this series on Netflix called Rotten. And so it's an investigative documentary series where they focus on the corruption of the global food chain. So it's kind of showing us where our food comes from and how we get it. And this particular episode was on, it was called the Avocado Wars. And it was about how 30% of the US avocados come from Chile, but in Chile, they're facing a water problem because avocados require a lot of water to grow. And so this series focused on Patorca area in Chile and how the La Ligua River was run dry because these huge avocado plantations were essentially funneling all that water from the river and from underground for themselves. And so it left the poorer people in the community, they had no water because the river had run dry. So it's very interesting to see how our food supply and our food demands affect other people in other countries who are producing the food for us. And then more relatable instance, more closer to home for us, is the Ogallala Aquifer. And so you can see a map here where that aquifer spans. It's rather large, but it's being drained faster than it can be replenished. And that water is being used for crops and livestock. And because of recent droughts, again, you can see how the water levels, if you look at the chart, are declining in many of the areas. So that's a closer to home example. And then here's just a couple of pictures from that Patorka region. You can see the riverbed has run dry in that community, but you can see the larger, more wealthier plantations still have nice green avocado areas because they have the money to dig further down to access that water source. And then the last energy source is fossil fuels. And much of the world's energy actually comes from materials formed hundreds of million years ago, which would be fossil fuels. But there are environmental consequences for it. Now, again, these are non-renewable. They include things like coal, oil, and natural gas, as you can see in the diagram. And about 80% of the world's energy comes from fossil fuels. But when these fossil fuels are burned, it's releasing carbon dioxide emissions into the atmosphere, creating those greenhouse gases, which turn up and trap the heat in our atmosphere. So there are there's negative effects to the fossil fuels. Not only are we having air pollution, which affects the environment, we also have the water pollution, which affects the hydrosphere. And then all that pollution is affecting the plants and animals, which goes again to impacting the biosphere itself. So again, you can see all the impacts that these energy sources have on those 4 subsystems that we mentioned earlier. And here's our last slide. It's just a quick little overview of where the US gets most of its energy from. And I have a quick little reflection question for you guys, and that is, how has the use of energy and water resources affected Earth's subsystems? So reflect upon what you learned in the PowerPoint and see if you can answer that question again. I know this was just a brief introduction, but the other teachers will go into further detail about some of these later on. So I'm going to go ahead and stop our screen share, and that's all I have for you guys on energy and water use and how it affects the Earth subsystems. We're going to give it to Dr. Gorman, and he's going to answer any questions.
Thank you, Ms. Ramirez. And the question came in, since there's so much water, salt water in the oceans, why can't we figure out a way to convert that to usable water? And this has been done to a small degree. Many years ago, I spent about 4 years of my life floating around on these huge ships. There were over 5,500 sailors and Marines on these ships, and we made our own water. It was a desalting process of some kind. It took the ocean water and it took the salt out of it and supplied water for us because there were way too many of us. We'd had to have another ship that big just to carry the water that we used. So that's something in the future, perhaps, to figure out a way to get the salt out of that water so we could use that water. I believe she said something like 71% of the Earth's surface is covered in water. And now Ms. Fuller is going to tell you all about mineral and rock resources.
Hi, boys and girls. Well, I'm going to talk to you a little bit about how the rocks, things that we dig out of the ground, affect the different subsystems of the planet. Now, this is a piece of lignite coal. It was dug out of the ground. It's a rock, but it's from carbon that was laid down about 325 million years ago. So let me set this down, and I'm going to share my screen with you. So under the overall heading of energy and resources, I have the section on the use of rock and mineral resources as they affect Earth's subsystem. So over on the left, you see all different kinds of coal. There's not just the soft brown kind that I just showed you, the lignite, but other kinds. Then we have gems, and then we have limestone. So those are the ones we're going to be looking at. Now, coal is hard to mine, and it's also hard on the atmosphere. If you look at the picture on the left, it's also hard on the environment, on the lithosphere. And it's hard on the human beings that mine it too. They ingest by breathing coal dust, and it causes a disease called black lung, which is very detrimental to their health. So we've got the different sections of the subsystems of the Earth. The lithosphere, The two damaging aspects of coal mining are surface mines and mountaintop mines. Now we've got a third type that goes very, very deep in the earth. But if you'll ever remember that song Paradise by John Prine, when he talks about asking his father to take him to Muhlenberg County, and his daddy says, I can't do it because Mr. Peabody's coal mine has hauled it away. And that's about mountaintop mines in Kentucky. The landscape has been severely changed by mountaintop coal mining. As far as the atmosphere is concerned, there is a type of methane released called coal bed methane that emits from the mines deep in the ground. And then when they're burned, they release SOx and NOx and carbon dioxide, particulate matter, sulfur, all kinds of things like that. It's not really good for the atmosphere. As far as the hydrosphere is concerned, I told you the third type of mines were those underground ones. Sometimes when they're abandoned, acidic water drains from them and goes into the groundwater. And then we have runoff from surface mines that runs into creeks and rivers. And the biosphere, anything that drinks water or breathes air that's contaminated by coal mining and its use are negatively affected. Now the cryosphere is the frozen part of the planet. And you might think, well, how can coal mining affect the Arctic? And it's very interesting. These little particles get in the air and are carried by winds, and they're deposited on top of the ice. And as you know, during the summertime, your parents encourage you to wear white or light colors instead of black, because you can get overheated because the black clothes absorb the heat and light from the sun. And the same thing can happen in the Arctic. It decreases the albedo, the reflective characteristic or quality of the earth, by blocking the reflection that white snow has, but it causes the black absorbs heat and causes the ice to melt. Now, diamond mining, we all like gemstones, we all like earrings and rings, but we have to make sure that the gems, whether it's diamond or tourmaline or opal, whatever type that comes out of the ground, that it doesn't damage the earth and it doesn't damage the miners. Now we've got a picture of a diamond mine down there, and the landscape is kind of wrecked from that. Diamond mining has been going on for well over 100 years. And because of the way it was approached a long time ago, there weren't a lot of safety measures for either the workers or for the lithosphere, and so they had tremendous topsoil erosion. Now, this particular mining does not use toxic chemicals, so they don't have that going against them. One of the things that they have done, though, they've rerouted rivers so that they could dig underneath the riverbed, and this has had devastating consequences for fish and other organisms that live in the river. As far as the biosphere is concerned, it can cause ecosystem collapse, deforestation, wildlife elimination, and abandoned mining pits can fill with water, which is a breeding ground for mosquitoes, which can carry malaria and affect the human population. And believe it or not, there is an effect on the Arctic, the cryosphere, because they've started diamond mining in Canada, but the Canadian government has made sure that the Canadian Arctic is heavily regulated, and this is to prevent diamond mining from destroying the environment in Canada. Now, limestone. Now, limestone's very close to home. We have a lot of Portland cement plants in Texas because we have a tremendous amount of limestone here. So limestone and the processes of it to make Portland cement are a heavy impact on Texas. Now, we've been using cement for anywhere from 10 to 12,000 years. It started in Turkey, and cement is the second most used resource in the world. So we do a lot of building and a lot of road construction with it. As far as the lithosphere, the crust of the earth, mining for limestone can result in sinkholes, landscape degradation, loss of agricultural land, and it looks like I've got an unfinished thought there. As far as the atmosphere, it puts out a lot of dust, and there are a lot of emissions from the machinery. Carbon dioxide emissions are let to the atmosphere, and carbon dioxide production from cement manufacturing is a major contributor to carbon dioxide in the world, one of the top. As far as the hydrosphere, it can affect groundwater. It can disrupt aquifers. You saw the Ogallala that Ms. Ramirez showed you. Aquifers are crucial because water is crucial, especially in the state of Texas, because we have so much agriculture here. It can actually lower the water table. And in Germany, when they were mining limestone for cement making, they were pumping a lot of salty water. There are a lot of salt mines in Germany, and it got into the local rivers. It was very detrimental. And as far as the biosphere, living organisms can be negatively affected from particulate matter and contaminated water. Reclamation is a solution for the lithosphere. We've got very strong reclamation laws in Texas. On the right, you'll see a strip mining operation from Fairfield, Texas, at the Big Brown mine, where they were pulling the lignite coal that I showed you out of the ground. On the left is what it looked like after the area was reclaimed. They've got very strict rules, what it needs to look like, what the soil needs to look like, but very often after reclamation, the land is actually more beneficial for farming and ranching than it was prior. So reclamation is a good solution to strip mining and other mines like this. So I'm going to stop sharing my screen. I'm out of time, and I'm going to give you a little challenge. Get a little piece of white paper and a little piece of dark paper and leave in the sun for a few minutes, and then pick them up and feel the heat difference. You'll be able to tell. I want you to reflect on the effect of coal dust on Arctic ice and record your reflection in your science notebook. So that's that. All right. So I'm going to turn it over to Dr. Gorman. If you have any questions, he'll be happy to answer them. Thank you.
Thank you, Ms. Fuller. And it's interesting that you covered the Big Brown mine, because one of the questions came in. Give an example of reclaiming the land locally. And this is down near Fairfield, which is not far from here. And the Big Brown mine started in 1971. And they started with the idea that they would leave the land better than it was when they started on it. They have actually mined and reclaimed over 15,000 acres at that Big Brown mine. And like Ms. Fuller said, the land is probably more profitable after they get through with it than it is. I happened to take a geology course at Mountain View College, located in Dallas, and we went on a field trip to the Big Brown mine, and it was really amazing compared to some of the ones in East Texas that I had seen, where they had just stripped the coal out and just left the land. So that is an example of them. The problem is when they burn the coal to make energy, it does pollute the air. So they're getting better about controlling that. So now we're going to let Mr. Monroe tell you about renewable resources, things that we can use over and over.
Hello, everybody. My name is Mr. Monroe, and we're going to be looking into a resource that is referenced as renewable. I have right here the perfect renewable resource. The 7 billion people that live on our planet today, for that 7 billion people, this is life sustaining. And everybody knows it is essential for life on our planet. It is water, H2O. Now, we're not going to be looking into a resource just because it provides life. And if you really think about it, it's more than just the 7 billion people that live on our planet. It's the plants that we have on our planet, and it's the animals that also depend on this life-sustaining substance. We're going to be looking at a source of renewable resources that we can use to get energy from. And for me to do that, I'm going to share my screen with you, and we'll get into the energy that is provided by renewable resources. So bear with me while I share my screen with you. Get into energy. Renewable energy, today's lesson is going to be focusing on that. So what is renewable energy? The definition of renewable energy is that fuels that can be easily made or renewed. We can never use up renewable fuels. Types of renewable fuels are hydropower, which is water, solar, wind, geothermal, and biomass. Solar energy is the sun's rays or solar radiation that reach the earth. It can be used to heat water and to heat spaces. Photovoltaic PV devices or solar cells change sunlight directly into electricity. Solar power plants indirectly generate electricity when the heat from the solar thermal collectors is used to heat a fluid which produces steam that is used to power a generator. Photovoltaic devices, solar panels, as you can see in this picture, convert the sun's radiation into what we call solar power. We have several solar power plants that are scattered throughout our nation. In this picture, you see another type of sun's radiation collector devices called a solar dish. In this picture, you see another collecting device that is used to collect the sun's radiation. It's called a solar power tower. Now, wind energy. Air in motion caused by uneven heating of the Earth's surface by the sun. Large atmospheric winds that circle the Earth are created because the land near the Earth's equator is heated more by the sun than the land near the North and South poles. So our planet goes through what we call uneven heating. If you know anything about air, warm air has a tendency to rise and cooler air has a tendency to sink. And so therefore, we have what we call convection currents. What I usually say is that those are natural wind-making machines. Two types of wind machines: turbines, used today based on the direction of the rotating shaft, its axis. Horizontal axes are the most common. Vertical axis. Clusters of wind machines are called wind farms. Hydropower energy accounts for 6% of the total U.S. electricity generated and 71% of generated renewables. Now, in the state of Texas, and especially around the Dallas Metroplex area, there are several reservoirs that have dams that were put there to create these reservoirs. And those dams basically are using the water in that reservoir to create what we call hydropower. Geothermal energy, and that's the heat from the earth. If you know anything about the structure of our planet, underneath the crust, it's quite warm. geothermal energy uses the steam and hot water produced inside the earth to heat buildings or generate electricity. It is a renewable energy source simply because the water is replenished by rainfall and the heat is continuously produced inside our planet, the planet Earth. How geothermal energy is generated. As you look at the structure of our planet, you see the crust and then the mantle, the outer core, and the inner core. Now, in the mantle, that magma is super hot, and that is just beneath the crust. Where do we find geothermal energy? Well, there's a ring of that deals with our oceanic plates, and that ring is what we call the ring of fire. And the mid-ocean ridges that exist in the Pacific Ocean and the Atlantic Ocean, there are openings that expose the mantle to the surface or underneath our oceans. Uses of geothermal energy: number one, direct use and district heating systems. 2, electricity generation. 3, geothermal heat pumps. Geothermal plants and heat pumps. Types of geothermal plants: there's a dry steam plant, a flash steam plant, binary power plants. Geothermal heat pumps are the most energy efficient, environmentally clean, and cost-effective systems for temperature control. Biomass energy. Biomass is organic material made from plants and animals. Biomass can be converted to other usable forms of energy like methane gas or transportation fuels like ethanol and biodiesel. Forms of biomass. Wood and wood waste are the most common forms. Municipal solid waste, landfill gas, and biogas are other forms. Biofuels, fuels made from biomass material. Biofuels don't burn as much as fossil fuels. Biofuels are cleaner burning and produce fewer air pollutants than fossil fuels. Types of biofuels is ethanol and biodiesel. And you know, when you go to the gas pumps nowadays, if you are filling up your tank or putting gas in your vehicle, you will notice that a certain percent of gas nowadays is a certain percent has ethanol in it. And the 18-wheelers that are using diesel now, a lot of those have been converted over to biodiesel. Now, this is a question that I'd like for you guys to be thinking about. Which forms of renewable energy can we find in where we live in North Texas, our geographic area? Okay. Now you might want to check out Get Energy, this active website, Get Energy Active. Okay. And it is an active website. Now I'm going to turn this back over. I'm going to stop sharing my screen. And I'm going to turn this back over to Dr. Gorman. And if any of you have any questions, maybe he can answer those for you.
Thank you, Mr. Monroe. The question is, what are the most popular renewable energy sources in the world? Mr. Monroe covered most of these: solar energy, wind energy, hydro energy, tidal energy, geothermal energy, biomass energy. And which one is the most popular? The hydropower is 54% of the world's energy is produced by water, flowing water. And I had an experience going up the Panama Canal a couple of years ago, and there was this big pipe coming off the middle of the mountains, and there was a big building at the bottom of it. And I asked the guy on the boat, I said, what's going on? And he said, there is a pond, a little river at the top of up the side of the mountains, and they have a pond up there, and they collect water in it. And when the pond gets to a certain height, they would open up the gates to that pipe, let the water go down that pipe, and it would turn a generator on the bottom, and in turn it produced electricity. The problem was when the pond got low of water up there, they had to cut it off and let it fill back up. So when it was cut off, they didn't have any water. Just like some of you probably didn't have any water a couple of weeks ago. It wasn't caused by that problem, but now you know how some of those people feel. Now, Ms. Nash is going to talk to you about non-renewable resources.
Hello, students. Welcome to my classroom. Today we're talking about non-renewable resources. And I got out my little poster here and I was looking at it and realizing how many of the things we use every day come from a mine of some kind. So anything that comes out of the ground, basically, from a mine or any kind of a well, except for water, is basically non-renewable. These are things that have been here for hundreds of millions of years, and new ones are not being created. So that's what it means to be non-renewable. Let's look at a few little pictures. Especially today is the 10-year anniversary of a disaster involving a non-renewable energy source. Okay. So we can compare renewable and non-renewable. Mr. Monroe just told you all about the renewable. So non-renewable energy is derived from coal, oil, natural gas, and nuclear energy. So oil, coal, and natural gas are what we call fossil fuels. Okay, put down the carboniferous. Okay, and lots of CO2 emissions and other noxious emissions from the use of all those. Nuclear is another case that we'll talk about in more detail in a moment. So there we see so if we go down to the Gulf Coast of Mexico, we can see these big oil drills out in the Gulf of Mexico. We can also see lots of wind farms. We have lots of wind in Texas, and we could be using more solar energy because we certainly have enough sun. And then all that smoke coming out of that coal plant. So our energy consumption, renewable, that Mr. Monroe just told you about, is a tiny piece of the pie. Okay, tiny piece of the pie. It's getting bigger and it needs to get a lot bigger fast as we can. So natural gas, okay, petroleum are the big ones. Coal is declining, thank goodness, because that's a really, really bad one for CO2 and all kinds of particulate matter and mercury in the water are really bad. And of course the tailings as they pile up after it's all over. And then nuclear power. So the use of fossil fuels, the mining, the production, and then all the accidents that happen. So we can drive around like that for the birds and animals, the water, the land, the air we breathe, all bad. So nuclear power plants. I had this argument occasionally with my brother-in-law about nuclear power. We have a difference of opinion, and that's okay, because he says, and I agree, that nuclear power plants, because they are not producing CO2, contributing to global warming, climate change that we just experienced with that polar vortex. It got really cold because of climate chaos, really. So they do not produce CO2. However, they produce dangerous waste products that we really have no idea what to do with forever. And you can have these catastrophic accidents. So here's one that we have the 10-year anniversary today of the meltdown at Fukushima in Japan. And there was an earthquake. So here they built the nuclear power plant on the coast of an area prone to earthquakes. And they had a big earthquake and a big tsunami came and it overwhelmed the power plant and they had a meltdown, a terrible, and people still can't go back. They don't know what to do with it. So another really famous one is the Chernobyl disaster in Russia. That was like 30 years ago, and you still can't go there. The ground is contaminated. Lots and lots of people died there, and they've had to abandon, leave everything behind. people died trying to put out the meltdown. Okay, they sent the Russian army and people, probably hundreds of people died. They built a gigantic concrete containment over it. That concrete will be disintegrating because of the radiation that's still there. This is a problem that we will leave to our great grandchildren. And in the meantime, the animals have come back. They've recolonized the whole area, and it's actually kind of interesting. You can look that up online about the Chernobyl exclusion zone, and tourists even go there these days. So coal and fracking is what we have in Texas, fracking. So these are fracking sites. These are fracking pads. Okay. If you go up in an airplane and fly between here, go west from here, you will see this covering the landscape. And at each pad, big trucks were coming in, they're putting out machinery, destroying the landscape, animals who live there, air pollution. So this is really what we have to deal with here in Texas. And they keep claiming that, natural gas is better than coal because it does not produce as much CO2 when it's burned. However, the problem is that these wellheads, of the fracking sites are emitting tremendous amounts of methane. So methane gas is a really worse gas for the climate. It doesn't last as long in the atmosphere, but in the meantime, it's like really bad. So we really need to think about what we're doing. Remember all that energy we're using to run our lights, to drive around in cars, we can conserve that energy. And the less energy we use, and we found out recently how cold we could get if we didn't have that energy. So we need to do something to keep warm and cool in the summer, but we also need to think about where it's coming from. So this is your planet, it's your decision, and we need to consider not only ourselves, but all the other creatures that share our amazing planet. And remember, the polar bear is your cousin too. Okay, so I'm going to stop sharing my screen here, and there we go. So when I looked at my little chart here, I started thinking all these things that you don't even think about, like the porcelain. Okay, this came from a mine. Feldspar was mine. Okay. The pencil, the graphite in your pencil was mine. The plastic, of course, is made with petroleum. This galvanized metal came from safflorite in Chile. And of course, our cell phones contain what we call rare earth minerals that are being mined at tremendous environmental and human costs, all over the world. So we really need to think about how we can recycle the things in these products, so that we do less damage to our planet. So lots to think about, lots to learn. And if you have any more questions, you can ask Dr. Coleman.
Thank you, Ms. Nash, and that is certainly something to think about. And somebody wants to know, what can we do to save the non-renewable resources? And Ms. Nash covered a lot of this, but it said to use the 3 R's, reduce, reuse, and recycle, and that will help to save. And now I am going to share my screen. During this virtual field trip, students evaluated how the use of energy, water, mineral, and rock resources affects Earth's subsystems. They also differentiated between renewable and non-renewable resources based upon rate of formation and use. Ms. Ramirez covered energy and water resources. Ms. Fuller talked to you about mineral and rock resources. Mr. Monroe covered renewable resources, and Ms. Nash covered non-renewable resources. Thank you, teachers. How did we do? If you would, go to www.tiny.cc/EEC feedback, fill out the short form and send it back to us. Okay, guys, we want you to have a great rest of the day. Want you to have a great life. And part of that is going to have to be renewing, redoing, renewing, and recycling. Thank you for joining us. Goodbye for today.